Assalamualaikum. Problem-based learning for subject further control system. We are going to present about Z transform. So our group members Ruslianita, Hanan, Farah, Wahidah and Farah. And our lecturer Dr. Lili Jamilatul Awalin. Introduction for Z transform. Z transform is widely used as an analysis tool for signal processing. It is most general concept for the transformation of discrete time series. It is also commonly used in the field of applied mathematics, digital signal processing, theory of control, and economics. It's a generalization of Fourier transform FT. Why? FT does not converge on all sequence. Its notation is good for analysis, and it brings the power of complex variable theory deal with discrete time signal system. The solution of differential equation Z transform corresponds to that used by Laplace transform. We will explain more about Z transform by using example. Z transform is defined using this general equation. The new signal xz equal to summation from k equals to 0 to n discrete time signal xk multiply with z power of negative k. And so we simplify it. Summation from k equals to 0 to n xk multiply with z power of negative 1 times k. And for the limitation, Z transform cannot apply in continuous signal. Z transform cannot analyze analog filter. Example 1. To find the region of convergence ROC if xn equals to 0.5n and the interval given negative infinity to infinity. For step 1, we need to expand the xn according to the interval. So we substitute the value of negative infinity to infinity inside the xn equals to 0.5n. Hence the value we got on the slide. Next is the step 2 by looking at the summation. We perform the summation from n equals to negative infinity to infinity, discrete time signal xn multiply with z power of negative n towards the infinity. For step 3, there are no values of z that satisfy this condition, so no ROC for this problem. ROC is centered on origin and consists of a set of rings, so the Fourier transform is used to evaluate the Z transform on a unit circle. On the next example, we will see how ROC applies.
Assalamualaikum warahmatullahi wabarakatuh. My name is Hanan binti Hassan. Now we will explain for example 2. Find region of convergence ROC if x n equal to 0.5 power of n un and interval given negative infinity to infinity. Un u is Heaviside step function. Step 1. Expanding xn according to the interval. We use equation xn equal to az negative 1 power of n. So we have to substitute 0.5 into a and n with 0 to infinity. Then the interval we got is xn equal to 1, 0.5, 0.5 power of 2, 0.5 power of 3. Next is step 2, looking at the sum. In this step, we have to convert signal xn to Z transform xz. Use table of common Z transform pairs. In the table, an un equal to 1 over 1 minus z to the power of negative 1. Or we can perform sum use equation summation from n equal to negative infinity to infinity xn z to the power of negative n. So we can substitute xn with 0.5 power of n. This example, we calculate the summation from n equal to infinity to n equal to 3. So we got the answer 1 over 1 minus 0.5 z to the power of negative 1. And we simplify the equation, we get z over z minus 0.5. To prove the answer, we use MATLAB and the answer is same. So we got the right answer. Step 3. To check back the equation, use inverse Z transform. In this step, we direct inverse using the table of common Z transform pairs. Xz equal to Z over Z minus 0.5. Our pools A equal to 0.5, so we can convert, use table. We got xn equal to 0.5 and un, so we got the original equation. Or otherwise we can use MATLAB to inverse Z transform. We also get 1 over 2 power of n. Lastly, step 4, determine ROC. ROC for this example is outer the circle. We can see that our ROC that is colored in pink. So this situation can be called causal ROC, and our system is not stable because the shaded region is greater than 1.
Assalamualaikum. I'm Farah Wahidah. Today I'm going to explain about example 3, which is known as anticausal of region of convergence or ROC. Okay, for your information, this type of ROC, which is anticausal system, is left side to the leftmost pole. Okay, let's get started. For example 3, we have to find ROC if xn is signal that is equal to negative 0.5 to the power of n u negative n minus 1, and the interval given is from negative infinity to the infinity. Okay, u is Heaviside step function. Okay, firstly, step number 1, we have to expand xn according to the interval given. So we will get the equation xn, general equation, which is xn is equal to negative an z to the power of negative n, and then we will substitute 0.5 into the a and solve this equation according to the interval given, and we will get xn negative 0.5 to the power of negative 3 up until negative 0.5 to the power of negative 1, 0, 0 and 0. Okay, moving forward to step number 2, looking at the sum. Okay, by changing xn signal to the Z transform using the Z transform table from the sequence of u negative n negative 1 sequence, we will get the last answer, which is 1 over 1 minus z negative 1. Okay, using the general equation xn z negative n, substitute 0.5 into xn as xn is equal to a to the power of n. After that, solve all this equation for sum of 0.5 and z to the power of negative n from n negative infinity to negative 1. After expanding this equation, substitute according to the general equation of 1 plus x to the power of 2, and we will get 1 over 1 minus x. So 0.5 to the power of negative 1z is here, and substitute 1 over 1 negative x into this. After expanding this equation, we will get 0.5 negative 1z bracket 1 plus 0.5 to the power of negative 1 z to the power of 1 plus bracket 0.5 negative 1 z to the power of 2 plus etc. And substitute into this general equation. So 1 is equal to 1, 0.5 negative 1 z to the power of 1 is equal to x, and this one is substitute into x squared, and then we will get 1 over 1 minus x, and then solve this equation, which is 0.5 negative 1z multiply with 1 over 1 minus x. 1 over 1 minus x in this equation is 1 over 1 negative 0.5 negative 1z. Okay, after that solve all of this equation, these questions, and then we will get back this z transform according to the table, which is 1 over 1 negative 0.5 z to the power of negative 1. In order to check back the calculation, manual calculation, we are using MATLAB simulation. So this is all the command and all the formula in the MATLAB simulation, and after substitute all the formula from manual calculation into the MATLAB simulation, we get back the answer after the Z transform is performed in MATLAB. Okay, moving on to the example 3 for inverse Z transform. Okay, for inverse Z transform, we will inversely change from Z transform back into X and back. After that, we will check using MATLAB simulation. So from xz equal to negative 1 minus negative 1 over 1 minus 0.5 z to the power of negative 1. Firstly, by using step number 1, find the zero and poles according to this xz transform, xz signal, which is negative 1 over 1 minus 0.5 z, negative 1. We will see that this is just a simple equation, not complicated, so we will easily directly get the xn by using step number 1 first. Okay, so firstly, just find the zero and poles. However, this equation have no zero, just proceed with poles equal to a. So in this equation, a is equal to 0.5. And then step number 2, substitute value a into xn. Xn is equal to negative a to the power of n u negative 1 negative n minus 1, and we will get xn back. Okay, so now we are going to check the answer using MATLAB simulation for inverse Z transform. Okay, firstly, use sims command and sims a and z. Okay, and then second one, assume a is more than 0, because in this equation a is more than 0, which is a is equal to 0.5. So a we are going to get a 0.5. A is the poles of this formula, this equation, and after that assign ifz equal to iz transform bracket negative 1 over a to the power of negative 1 minus 1, and then sign back ifz equal to iz transform negative 1 over 1 minus a to the a multiply z to the power of negative 1 from xz transform that we got z and n, and then assign ifz is equal to simplify ifz. So after that press enter, and we gonna get the answer back, which is negative 1 over 2 to the power of n, or negative 0.5 to the power of n. That's all.
As shown in figure 6 is an anti-causal ROC. By using the infinite geometric series, the equality only holds if 0.5 minus 1z less than 1, which can be rewritten in terms of z as z less than 0.5. Thus, the ROC is z less than 0.5. In this case, the ROC is a decentered, as shown in pink color. The unity circle is the outer circle, which is equal to 1, while the circle that is in the center is z equal to 0.5. In conclusion, to craft a system that actually useful by virtue of being causal and Bible stable, we must ensure that it is within the region of convergence, or known as ROC. It can be sure by looking at the zero point. The function exists when the ROC is at the area in the zero plot of the transfer function. This can be seen in example 2, where the causal system is extend outwards, while for the anti-causal system, the ROC extend inwards. Thus, this Z transform can be calculated in 3 different cases of region of convergence, as given in example, which is low ROC, causal ROC, and anti-causal ROC. It is shown that the Z transform xz of xn is unique, and only when specifying the ROC that can be seen in our 2 examples. The ROC cannot contain any poles. It is shown that the system is stable if the unity circle is included in the system. Thank you.